Hello everybody! In this video we're going to be talking about changing rows and columns of NumPy arrays. So here, just to get started, I've already imported NumPy, and if you recall from a previous video we saw how to make an array that looks like this. So the first row is all zeros, the second row is all ones, and so on, and I'm going to call this array ARR. Now, first thing we're going to talk about is how could I, let's say I wanted to change this row of all twos. What if I wanted to change that? So one way that we can do this is the way I can access the second row is I call ARR and then square brackets 2. And you can see here this gives me the second row of ARR. Now what if I wanted to change this so that everything in that row is 9? What I could do is say ARR square brackets 2 is equal to 9. And then if we look at ARR, we can see here, this row used to be all 2s, and now we've changed it to be all 9s. So that's how we could do changing rows. What if I wanted to change columns instead? So what if I wanted to change this first column here? So let's say I want to make that all -5. And the way we do that is we say ARR square brackets. Now I'm going to use colon, comma, and that means take all of the rows, change, now I'm going to say the first column to be -5. And then if we look at ARR, we can see here that the first column has been changed so that it's all -5s. So here you can see we used this colon to mean take all of the rows. We could have done something very similar instead of taking ARR of 2 like we did up here. So for instance, let's say I wanted to change the third row now. So I could say ARR, I'm going to say take the third row, give me all of the columns, and let's make that 5. And if we take a look now, we can see that the third row has been changed to be all 5s. Cool. Now, maybe one thing I want to show you is let's start by defining a variable v as, I'm going to say it's ARR, take all of the rows, second column. So then if we take a look at v, we can see here this is 0, 1, 9, 5. And this corresponds here to this second column of ARR. Now what I can do is I can call v.shape. And we can see here this is a one-dimensional length for NumPy array. Now for instance, maybe I wanted to do something like this. So why is this relevant? I can do ARR of 3. So this is saying give me the third row, or maybe even to make it, no, let's stay like this. So let's say give me the third row. And what if I want to set this equal to 2, 10? Now think about this for a minute and see if you can figure out what's going to happen. So if I run it, notice I get an error here, and it's saying could not broadcast input array from shape 2 into shape 4. So what's going on here is we're saying ARR of 3, so take the third row of ARR and set it equal to 2, 10. Now it might be nice, it might be a good intuitive way to think about it as I have 2, 10, 2, 10, like it keeps repeating. But this isn't actually how NumPy is coded to work. So what we'd need for this to happen is I'd need the dimension of this matrix or NumPy array here on the right to match the dimensions of the row I'm trying to change. So notice here the shape that I give it is 2. It's one-dimensional length 2. And I need it to be 4. So for instance, if I wanted this to work, what I could do instead is say ARR of 3 is equal to 2, 10, let's say 2, 10. And then there's no error, so let's take a look at ARR. And now we can see here this last row got changed to 2, 10, 2, 10. Another example I want to show you, so if I do ARR of colon, so this means take everything, and what do you think is going to happen if I set 1, 3, 4, 7? So try to make a prediction. And really there's no good way of kind of knowing ahead of time what this is going to do. But let's take a look. So we can see here, it changed the first row to 1, 3, 4, 7, second row to 1, 3, 4, 7, and so on. And the reason for this has to do with something called broadcasting. So broadcasting is something we're going to talk a lot more in depth about in the next video. But for now, here's a quick overview of what's going on. So for instance, if I take a look at arr.shape, you can see here I get 4 by 4, 4 rows, 4 columns. Now what I'm going to do really quickly is I want to convert this list here into a NumPy array just so I can call shape on it. So I'm going to say w equals np.array of this list. Oops. Then what I can do is I can call w.shape, and we can see here that it's a one-dimensional length 4 NumPy array. So the way broadcasting works is it looks at the dimensions of the two things that you're trying to either add or concatenate together, and it goes from right to left. So the rightmost element here is 4, rightmost element here is 4, and because these match each other, what's going to happen is this NumPy array, it's going to correspond the 0th element here to the 0th column of ARR. So 1 gets sent across the 0th column, then 3 gets sent along the first column, 4 along the second, and 7 along the third. So here, the 4 and the 4 matched, and that's why we were able to get this example that works, versus in this example we tried earlier, this here was 2 and it didn't match 4. So like I said, we'll see a lot more examples of compatible dimensions in the next video. But let's see, maybe one more example we can look at. So I'm going to copy paste the array that we started with. So instead of it being a 4 by 4, I'm going to make it a 5 by 5 just to make things a little bit more interesting. So I'm going to start by saying np.zeros make a 5 by 5 array of integers, and then for I in range 5. So here we have a nice 5 by 5 array. Now what I'm going to try to do is, instead of using a for loop to create this array, I'm going to try to do it using just broadcasting. So let's start by making a blank array. So I'll say arr equals np.zeros 5, 5, and I want it to be integers. Then what I'm going to do is I'll say arr take everything, and I could do np.arange of 5, and again try to predict what's going to happen here. So let's take a look at arr. Oops. And we can see here it's pretty close to what we want, but notice the rows and columns are flipped. So the first row is all, or the first column is all zeros, second column is all ones, and I want it instead to be first row all zeros, second row all ones, and so on. So a couple of different ways that we could fix this. So notice, like I mentioned, the rows and columns are swapped. So one way that I could fix that is just by taking the transpose. So the way I do that is I say arr equals arr.t for transpose. And then I can see here, this gives me exactly the array that I had wanted. What about if we didn't want to make it using the transpose? So another way that we could do this is I could instead say arr, again take everything, np.arange, again 5, but now I'm going to reshape, so maybe even before we do this, let's take a look at np.arange of 5. And we can see here, let me call shape on this. So we can see here this is a one-dimensional length 5 NumPy array. Now what I can do is notice the dimension here is going to match along the column's dimension of arr. So arr is 5 by 5. So instead I want this to have a shape 5 by 1. So what I could do instead is I could say arr take everything, np.arange of 5. Now I'm going to reshape this to be 5 by 1 instead. So 5 here to match the 5 here, and 1 meaning 1 in the columns dimension. So now let's take a look at ARR. And we can see here it did exactly what we wanted to. So again, let's take a look at what this guy looks like. So we can see here, this is, let me call shape on it. Maybe I'll name this Z, just so we can have it named. So notice here, Z.shape, this is 5 by 1, and the shape of ARR is 5 by 5. So another broadcasting rule is if one of the dimensions is 1 and 1 is 5, this 1 gets stretched to be the length of the 5. So what that means here for us is this 0 gets stretched along the column's direction. So 1, 2, 3, 4, 5. Whereas now we know that the 5s here match in the rows dimension. So this element is going to be broadcast along the rows. The 1 is going to be broadcast along the row here, and so on and so forth. So like I said, we're going to be talking a lot more about broadcasting in the next video, but this was just kind of some of the basic ideas behind it. One more thing that we could do, so notice here the only reason I had the 5 and the 5 was so that these dimensions matched. One thing that you could do instead, so I could do ARR of everything, np.arange of 5. Now when I go to reshape it, I could put -1, 1, and what this -1 does is it's a nice shorthand for saying make this whatever dimension it needs to be to kind of work in this example. So in this case it would be 5, but maybe there's kind of more things going on and I don't want to have to compute what this value should be every time. So the -1 just says make it so that it works with what I need it to. So here, again, we can see it gives exactly the array that I want. Maybe one more example, I could do ARR.reshape -1. And before we do this, let's remind ourselves, well, I guess we already have ARR here. Oops. So notice here, ARR has 25 elements. So if I do ARR.reshape -1, what this means is give me a one-dimensional NumPy array that fits everything in ARR. So this should be a length 25 one-dimensional NumPy array. So let's take a look. And we can see here, this certainly looks like there's 25 elements, but we could even check by calling shape. And yep, we can see one-dimensional with 25 elements. I think this is a good place to stop the video. In the next video, we're going to be talking again, like I said, about broadcasting rules in more depth. And then after that, we'll get into some timing in NumPy. Thank you for watching, and I will see you in the next video.